All right, in section 7.2, we were doing hypothesis testing on proportions or percentages. And in section 7.3, we're going to still be doing hypothesis testing, but we're going to test for a mean this time instead of a proportion. So when it comes to the kind of test we do when we're testing for a mean, what is called a t-test. You're going to find a lot of similarities between how we tested for a proportion and how we test for a mean, basically other than what kind of test it actually is that we are performing. So let's say that we know in 1990 the mean height of women 20 years of age or older was 63.3 inches. And today we take a random sample of 40 women and find that their average height is 63.9 inches with a sample standard deviation of 2.2 inches. Do we have enough evidence today to say that women are taller than they were in 1990? And we're going to test at the 1% significance level. So the first thing we need to do is make sure the sampling distribution is normally distributed. We talked about this back in chapter 6. Two things have to be true. We either must know that the random variable is already known to be normally distributed, or we have to know that the sample size is greater than or equal to 30. In this case, we have the sample size greater than or equal to 30, so we can perform a t-test. For writing the null and alternative hypotheses, again, same thing we've been doing. So the null hypothesis is that the mean, make sure you're using the symbol mu, is 63.3 inches based on our 1990 data. And the alternative is that women today are taller, so they are greater than 63.3 inches tall. All right, so find the sample mean and the sample standard deviation. If you can't find the sample mean and the sample standard deviation in this problem, there's a definite issue going on because you're given that information. So X bar is 63.9 inches. The standard deviation, which is S, is 2.2 inches. So that was given to us, should not be difficult to find at all. All right, to find the test statistic, so now we're going to have to figure out how to do this test on our calculator. So just like before, go to Stat, arrow over to Tests, and then you are looking for the t-test, which should be like the second one probably on your calculator. Again, some differences, and I guess on my calculator it's a capital T that they're using. So you'll choose a t-test, again likely number 2. Okay, then you have your choice of data or stats as your input. Okay, so what is your input? Is it data or stats? Data is when you have a list of numbers, like a list of things to put in, all the individual 40 values for those women's heights, okay? In our case, we have stats, we have the summary. The average height was 63.9 inches, and the standard deviation was 2.2. So go ahead and choose stats. Then as you work your way down, you're going to get the null hypothesis, so 63.3 inches. It's going to ask you what X bar is, that's the 63.9 inches. It will ask you what the standard deviation is. Again, we use S, the calculator uses SX, 2.2. N is 40. And we are testing in this case that we are greater than 63.3 inches, so the greater than part, and then go ahead and go to calculate, and it's going to tell you the test statistic. So that's the T that comes out, first number you'll see, so 1.7249, okay? There is your test statistic. Now, the next thing you're asked for, and I apologize here, when I downloaded, I didn't download enough pages, so this one's going to come in, hang out on top here. Okay, find and interpret the p-value. So the p-value, again, taking that off of your calculator, is 0.0462, okay? Now, what does that mean? So this means assuming women are, on average, 63.3 inches tall. So that's the null hypothesis. So assuming the null hypothesis is true, the probability of getting this particular sample is 4.62% or 0.0462. In other words, not very likely that that would happen, okay? But it obviously it did. So decide whether or not to reject the null hypothesis based on the level of significance for the test. So again, think of your curve here. We're doing a right-tailed test, and we were looking at the 1% level of significance. So remember, that means that 1% of the area is in that little tiny tail, okay? Our p-value of 0.0462 falls over here, okay? It is not in that smallest 1%. So in this case, we would say that we would not reject H sub 0. We do not reject the null hypothesis, okay? So what is our conclusion? There is not enough evidence to support the claim that women are taller now than in 1990. Okay. And just a little bit of food for thought. Had that level of significance been given to us at 5%, notice that we would have rejected the null hypothesis because that 4.62% would have been in that most extreme 5%. So that level of significance actually does have a bearing on what decision it is that you make. All right, in the next example, we will be looking at how you do the same test, but when you have data instead of statistics. So on to the next video to do example number 1.